Hello, we are here for one more lesson of this T-FLEX analysis training course. Today will be our last lesson of this set of videos. First, let me thank for being with us for all of these videos. I hope that they benefit you in your work, in your study. Any help, you know already that we are here to support you. So today we will see an example and speak a little about this example. You can see more examples in our channel also, but today it will be a little different because we will speak at the same time that we are showing. So we have a microchip here. We will create two studies. I have them already prepared to avoid losing so much time creating all the things. Let us see first one thermal stationary that you know already how to create it. Going to new study and then choosing stationary thermal study. After creating a mesh, okay, I've used a curvilinear tetrahedron with 0.1 in size, so nothing much different from we spoke already. And the idea it is to evaluate the efficiency of this cooling radiator. We have two bodies, two solids. This brown one that represents the ship, and this is the radiator. So when we go to material, we see that we have one material in aluminum, the top one, and another one in copper for the chip. Okay, nothing different from what we spoke until now. Then we will apply the loads, and the loads are first one applied to the solid below, which I've defined as a heat power 15 watts. So this is the maximum dissipating power. And the other one applied to the radiator, where I've defined two things. First, 25 watts per square meter as a convection parameter, and an environment temperature, working temperature of 25 degrees Celsius. So having all of this done, just simply go to solve, and we can get some things about this, but this does not vary in time. Let us simply say okay, and we'll have a calculation that corresponds, and I need to change this, corresponds to a temperature that we obtain in this system. So it is a stationary, so there is no change in time. It's calculated for a moment. I said environment 25. No, I had a 55 degrees Celsius in terms of environment, which is above what we usually would get. Then we have another one, new study, this time a non-stationary study, which has the purpose of calculating the time of heating up the radiator. So the idea it is to create a study, also a mesh. It is the same, and the only difference it is that I have a convection also in this radiator. The other one it was 15, now 25 watt per square meter at an environment temperature of 25 degrees Celsius. So let us say solve, and in this type of study, time it is important. So I will process time in terms of minutes, 30 minutes, half a minute, 30 seconds per increment, and I can get these thermal result studies or not. Okay, I can use temperature, for example, 25 degrees, and let us calculate to see what happens. done, and I have results. This time, let us take these guys out. Let us do extreme and parameters Celsius. Okay. Let us do animation. So as you can see, it has some variation, which we can control also. So we can go around here. I'm not sure what parameter I've missed, probably some initial condition to have such a lower value, but you know that after approximately 15 minutes it will reach the 25 degrees that then became more or less steady. Okay, this is we must have we should be careful with the definition of I define 25 Kelvin, which is very low, so Celsius, sorry. Let us calculate it again because I don't want to leave this message. Okay, now it should be a little different. Let us, and resulting parameters again in terms of Celsius. Okay, starts in 25 and it does not change, which it is also because I think always at this working environment. Let us change these also to, for example, 55. Okay, and do another calculation. Okay, now we should have a variation, because if everything is on 25, then okay, again, I need to put this by default. Boundary conditions. Okay, now we can see that temperature will start to increase until basically approximates to the 55. Okay, and will start. So we can, these are some considerations that we can take out of these studies, and with some practice for sure we will have also some efficiency doing this type of analysis and taking the results out of this. So again, and to say goodbye, thank you very much for being with us. Any help, any explanation that you might need about this, let us know. See you in other videos in the future.